Yes, trying to do that. Hello and good afternoon, Barcelona.
Yeah, please go ahead.
Yes, you have already my share screen.
Yep.
There you go. Yes. So yeah, thank you very much for those very nice introductory words about Igalia. I will also introduce a little bit myself. I'm Andre. My name is Andres Gomez. I'm an engineer with more than 20 years of experience in the Linux environment ecosystem. I've been working basically in almost every place of the software stack in the Linux ecosystem. So from being system administrator to then work in the development for desktop platform, mobile platforms. I've also been working in web engines, and the last things that I've been doing is actually working in the Linux graphics stack, and finally as the core and kernel coordinator in the company. As it was introduced, Igalia is very well known, or not so very well known, but we are best known, let's say, for the work that we do as a web engines developer. We are the second main contributors to Chromium and WebKit, but that's not the only thing that Igalia has experience on. We have been working for these 20 plus years in areas like multimedia and also as commented on the graphics stack. So we have a lot of experience also with OpenGL, Vulkan, and we are members of many of the usual consortiums doing specifications and standards for web engines, multimedia, and graphics. And because of all that experience that we have, then we have the experience also on working in integrating our systems in embedded, in the desktop, and also in servers. In this talk, I was wanting to actually focus on the expertise that we have actually in this work that we do, doing the integration of the work we do and the customers that we work with do into the operating systems, and how the operating systems should be thought for the future, how should be managed and deployed. So to begin with something quite simple. So what is an operating system? Well, we can think of an operating system like a kernel, a file system, a set of services, like a programming platform, of course, too, and an environment to run applications. But in my opinion, the most important thing is it is actually a series of policies for structuring the environment and keeping it up to date. So what is also an operating system for? More importantly, what an operating system is for is mainly for running at the very least one application, maybe many more, but that's the main goal of the operating system, just running at the very least one application. That application can be your entire desktop session, but it can be an appliance, or it can be a single task thing. Traditional Linux distributions are summarized in this slide. Basically, trying to make everything very simple, we have the two categories of custom operating system images built from scratch, which traditionally are mainly targeted for the embedded devices, and they are not so much intended to be modified. So maybe not even updated in the long run. So quite often, what happens with them is that they stay as they are once they are deployed. And then we have the other one, which is the model of the package-based distributions, which are mostly oriented to servers and desktops, and they are customized by the end user. And in this case, we actually contemplate updates and upgrades. The limitations that we have for the first category of this kind of OS-built images is that they are vulnerable. They are quite vulnerable to changes in the base system, and they are also unstable in the sense that accidentally you can modify or delete the whole system, and there is the possibility of having a broken status if you do a partial update, and they don't usually have rollback support. Additionally, another of the limitations is that they are too tightly integrated with the system itself. The apps are very dependable on the base system. And finally, they are also difficult to manage. They have to go through the process usually of offline updates and upgrades, and there is no rolling release. So in the end, that leads to having a very old system with unresolved security vulnerabilities. In the case of the package-based distributions, the limitations are shared with the OS image flavor. And we add some others that are triggered actually because of the aim that they are trying to fix from the previous one. So again, the package-based distributions, they are vulnerable also to changes in the base system. They may be unstable because of accidentally modifying or deleting the base system, and they can also get to a possible broken status due to a partial update, and they also don't have rollback support. As with the previous one, they are also tightly integrated with the applications and the application also depends on the base system. And additionally, in this case, we have the problem of fragmentation. So actually, there is not just one single distribution, but actually you have as many distributions as installations from every of your users, because they may have added different packages, and in the end, it's very difficult to have the complete chain of dependencies. And additionally, they are still difficult to manage. Even when you have added the packaging on top of the distribution to make it a little bit easier, there is still limitations. You may add the possibility of having online upgrades for some of your applications, but often doing an online upgrade will be leaving the status of your system in an unstable way. And there will be also different degrees of release cadence depending on the distribution. So in the end, you may still find yourself with an old system with often some unresolved vulnerabilities. So now we wanted to talk about in Igalia the concept of the next-gen Linux distributions. We have in our mind to intertwined focus on this trend of next-gen Linux distributions. The first focus will be the immutability, and the second focus will be reproducibility. And let's see the first one. For immutable systems, the characteristics that they qualify one of these systems is that they are read-only. This is the primary characteristic. So the running system cannot be directly modified by the users or applications. They also provide atomic updates. So they are successfully applied all at once or not at all, meaning that you cannot get to a broken status. They are also predictable. So once you have your system for one device, basically the behavior should be replicated without any problems across different devices. And you have also the model of isolated applications. So the core operating system, they are isolated from the core operating system and from each other. Changes made by an application won't affect the core system or other applications. The advantages of this kind of systems improve security. So it's more difficult to malicious software to make changes to the system or to spread from one application to another. They will be improved.
还有稳定性也可以得到提升，不会因为事故而被修改。
There is also the characteristic of reproducibility. So it's easier to test, to audit, and also to verify the system, as well as to diagnose and troubleshoot issues. And finally, it is in improved manageability. So system administrators don't have to worry about unexpected changes or inconsistencies between different systems. Thanks to the atomic updates and rollbacks, it is much simpler, the process of applying systems and updates and fixing issues. Disadvantages of this kind of systems is that you have a reduced flexibility. So the users cannot customize their systems to the same degree. There is also some limited compatibility because not all the applications and services may be compatible with this model of containerized and isolated environments. And there is also the problem of the storage requirement. Due to the mechanism of update with support for rollbacks, you will be needing extra storage. And the isolated applications may also lead to having redundancy in the storage of the application dependencies. Finally, the developer experience may not be great in this focus of immutability because the containerized development environments include additional complexity complexity, and limit the use of familiar tools and workflows. Different approaches that we have for immutable systems, from using the traditional distribution based on packaging, like the Debian DPKG or the Red Hat RPM, with the featuring of having snapshots provided by the file system, like BRTFS, or using LVM. Then we have also the model that is provided with the AB process, the very well-known AB process that is used in Android, and also in the Linux environment, the main example will be Chrome OS. Then we have the approach brought by the use of OS3 and containers and sandboxed applications. OS3 is like Git for binaries. So it minimizes the storage and bandwidth by only shipping deltas for the changes. And it provides an immutable-based system and isolated apps by this mechanism of containerization provided by engines like Docker or Pullman, or sandboxing applications with Flatpak or AppImage. Then we have also the approach of RPM OS3. In this case, OS3 is also used, but it is applied in a way of layers that are on top of each other, providing the mechanism also of using packages. And this provide an additional flexibility to provide more applications and be able to change the system. And finally, Ubuntu has the approach of snaps. They segment the system in different user spaces that are each of them a different snap that can be updated and rolled back at different cadences. And then there are multiple other approaches. Some of the examples that you can see there from systems that provide this immutability are from SUSE's Micro OS, Chrome OS, Endless, SteamOS. We have a long experience with SteamOS, for example. We have been working with Valve for a long time, working in their immutable system for the Steam Deck. Horizon OS, Fedora Silverblue, and Ubuntu Core. Then we have the problem, as commented, of how do we run applications that are not part of the base system. We have basically three mechanisms, as I was introducing before. Sandboxing the applications. The main technologies that we use for sandboxing nowadays is Flatpak, but Flatpak has the limitation that needs services that are typically found in the user session, like dbus. And therefore, they are more suited for desktop applications by extending, but it's extending itself to use by non-graphical applications. Then we have also Snap, which is more oriented to the server side. And the limitation is the opposite of Flatpak. It's not so oriented to desktop and has some limitations in the integration with the desktop. Both Flatpak and Snap are closing the gap in opposite directions, and they are getting closer to that. There are other sandboxing models like AppImage and other solutions out there. Then we have the OCI containers like Docker, Pullman, Systemd, and Spawn. And they are traditionally more suited for server applications, but it's not restricted. So they can also be used in other kind of environments like embedded or desktop or any other model that you can think of. And in this one, the developers can work with containers for creating their devel environment with DistroBox, Toolbox, etc., etc. And then finally, we have the approach that is bring by layering, like I was commenting before with RPM OS3. In this case, it's just a mechanism of using packages, but you have the possibility of layering different levels on top of each other to provide that flexibility. Then we have the other approach or the other focus on this kind of next-gen distributions, which is the reproducibility. The main characteristics of these reproducible systems is having isolated builds, so packages that are built in isolation from each other and ensuring that are reproducible without undeclared dependencies. They have declarative configuration, so the entire system configuration is described in configuration files, and in that way they ensure reproducibility. So it's making it very easy to manage and replicate the system configuration and the system in different devices. Once you have a configuration set to your own needs, then deploying it is as easy as copying that configuration and letting the mechanism to work. And then they have also the characteristic of using functional package management. So they treat the packages like values in pure functional programming languages. They are built by functions that don't have side effects, and therefore they never change after they have been built. Advantages of these reproducible systems is that they are replicable. This is the main one. So the clarity configuration, as I was commenting before, makes it very easy to create a replica of the current system elsewhere. They are reliable because the isolated dependencies are ensuring that the upgrading one package won't break another package. And they also provide atomic upgrades and rollbacks, which means not leaving the system in an inconsistent state. They are also flexible. This is maybe the main characteristic that is in contrast with the immutable system. So they provide the support for multiple versions of libraries, and they are able to change the base system safely and keep custom packages even on the system. They are very close to the developer experience, and they are enabling experimentation. So these kind of systems may be also very well suited for scenarios in which you have a very quick development pace in which you want to deploy changes as quickly as your developers are able to provide them. Disadvantage of this kind of reproducible systems is the storage requirement. Like in the previous immutable systems, the isolated builds lead to redundancy in the storage of dependencies. Typically, they are non-compatible with the Linux standard base. So for the regular user of or consumer of Linux distributions, they will be feeling a little bit odd out of place because the file system layout is very different. They have also limited availability of packages, even when they quite typical may have as many as 80,000 packages. They still need to migrate your package to be able to have it compatible with this kind of system. And they are also kind of complex and poorly documented. So it's a different paradigm, and that increases the complexity. The system deployment is very tightly related to the functional package management and is not widely adopted. The examples that we have, the typical examples that we have for these reproducible systems are systems like Nixos and Gix. And conclusions from these two approaches is that the current model of Linux distribution is showing its age. And this new trend of next generation Linux distributions is focusing on immutability and reproducibility. In the case of immutability, the main characteristics and advantages that we can get from them is the security and enhancement of the security, improvement in stability and manageability. And in the case of the reproducibility focused ones, you have one configuration that always works, and it works in any kind of different device. These two focus are especially interesting for servers and devices for the Internet of Things. They are actually very good for continuous integration thanks to their reproducibility characteristics. And there is the need on both of these approaches for a reliable application channel provider. So one of the things that happens is that because you have to get these isolated applications and you want to keep them also your system safe, the best way of having these applications is through providing a channel provider and not just having the applications coming from any kind of source, let's say. The use case of the desktop is also converging. So these models are very good for server, as commented, Internet of Things, embedded, continuous integration. For the user experience, the developer user experience on desktop is still a little bit not so flexible as we would like, but it's converging into that. So I think this is the trend that is going to go in the future, and Igalia is actually embracing these two focused models, and we are making a lot of development in this area and trying to bring this new paradigm to our customers. So thank you very much.